All right, welcome everyone to the last talk of the whole conference. Thanks for sticking out to the bitter end, spending it with me. I think you'll find this talk is very complementary to Matt's talk on iBeacons yesterday and Julia's talk this morning, the keynote. I think you'll find this just carries on right from there and will complement them very nicely. My name is Justin Collins. You can find me on the internet at President Beef. I work at Twitter on the application security team. I'm also a PhD candidate at UCLA. And you may know me from my work on Brakeman, static analysis security tool for Ruby on Rails. I'm not going to talk about that today, which is rare for me because I almost always am talking about it. But today I'm going to be talking about mobile ad hoc networks, why I think they're about to just explode, and why we aren't really ready for them to explode. And we need to get ready, I think. I think it would be a good idea for us to get ready. So I'm going to talk about mobile ad hoc networks, generally abbreviated as MANET. So I'm going to say MANET because mobile ad hoc network I've been saying for the last 2 days over and over again, and it gets really old. Some people say MANET. And if you search for MANET, you will probably come across this guy quite a bit. Totally different. So let's start off with a little bit of a scenario to get us started. You're staying at some hotel, just random hotel in some random city. And your friend comes by, they're outside somewhere, they've got their phone, and of course they're going to send you a message and they're like, hey, I'm here. They want you to come down and meet them. And of course it's going to go to your phone, right? And the question is, how does it get from their phone to your phone? I don't know. This is the way I think it generally happens, okay? They type the message, they send it, wireless signal goes out, it goes to a cell tower. From the cell tower, it goes somewhere, I don't know. It goes through a bunch of wires, through that provider, through other providers, ends up in the internet. But we all know the internet doesn't look like a cloud. It actually looks like this. So it goes through there, comes back out, goes through who knows what networks, goes back to a cell tower. It might go back to the same cell tower. It might go back to a different one. Sends out a signal, finally goes to your friend's phone. Whoop, they get your message. Hey, I'm here. That was a long ways to go. It could have been miles and miles when they're like, not that far from you, right in the hotel you're outside, or they're outside, you're in the hotel. Either way. Now, if they're right next to each other, they could just talk directly, right? They could use like Bluetooth or something, near field communication, Wi-Fi, whatever. But what if they're kind of close, but not close enough to hear each other? And what if there's somebody else there that can hear both of you? Then they can relay the messages in between. And now, we have a MANET. A MANET might look like this. A bunch of different devices, all, fairly mobile, all talking to each other, all relaying messages to and from each other. Or it could look something like this. Maybe a whole bunch of people, maybe a conference like this, maybe just out in the world. We all have, not all, but increasingly the majority of people have some smart device that's capable of doing this kind of communication. And of course, this is actually a pretty small area, but you can imagine large clusters of people moving around in a city or other area, all communicating with and through each other. So I wanted to kind of summarize what makes a MANET different. And this is what I came up with. It's a decentralized, self-organizing, infrastructureless, those are all kind of the same idea, multi-hop, so that sets it apart from a lot of other networks. Multi-hop wireless network, of course it's wireless. And we have mobile devices. And the mobility of the devices really sets it apart from most of the networks we're used to dealing with. So I'm going to go through these. Obviously it's decentralized. There's no central server. There's no central authority. There's nobody that you can go to and say, hey, what's going on in this network? Everybody's kind of on their own. Of course, these aren't really links. Actually, that's not what I was going to say. What I was going to say is they have to organize themselves. So when it starts off, nobody knows what's going on. They have to find each other and build up these links. Again, no infrastructure. There's no cell towers, there's no routers, there's no access points. It's just device to device. And it's multi-hop. So if this laptop wants to talk to that tablet, it needs to go through several wireless hops to get there. And it has to figure out this route between the two nodes. And of course, these are not real links, right? It's all wireless. And wireless has its own set of problems and challenges, which I'll talk about a little bit more later. And of course, these nodes aren't static. We're all moving around, right? We have a Windows phone all of a sudden. We didn't have that before. The BlackBerry disappeared. There's a different configuration. And you can expect in a MANET that this is, people are moving around. The network is going to be constantly changing. People are going to turn their phones off. Apps are going to crash. They're going to leave. New people are going to show up. Batteries die. So it's always changing. And that is just a really challenging environment. So let's look at, these are the standard examples you will see. I think it might be required by some law to put these examples in a presentation about MANETs. I'm not sure. But I do it just to be, safe. So of course the military. This is the biggest example. You've got units, they're all over the place, they're all talking to each other. Of course, MANETs primarily developed by the military. A lot of the research is military. A lot of it goes back to the 1970s with DARPA, packet radios. So, of course, a lot of people, they talk about the military application. The other one is disasters. All right, everything's wiped out. People go in, they need to rescue people, they need to share information with each other. They've got their devices, but there's no infrastructure. The cell towers are gone, the internet, there's no internet access. Well, let's look at some, I say better examples, but maybe examples that are, more likely to occur and maybe less disastrous. One is we just don't have cell service. We're in a basement somewhere, we're in a dead zone. We still like to talk to each other. So maybe we can use a MANET there. Classrooms, pretty good place. So what happens like today in a classroom? Well, I don't know, the school is wired up, they have their access points maybe in each classroom or something, maybe in the hallways. I imagine there are a lot of places where that's not really a feasible option. Well, what happens if the teacher comes in, sets up their machine, students come in, they have their little devices, suddenly you have a network. You don't need an access point, you don't need the internet. They can just talk directly to each other. And that is really, that's really self-organizing ad hoc network there, right? There was no pre-planning. They just came in, boom, it gets set up. Games are a great example. These ladies are playing Nintendo DS, communicate with each other directly. Over here, they're playing Space Team. Have you guys played Space Team? I love Space Team. It gets old after a little while, but it's like, oh my gosh, and the more people you have, it's crazy. And it has the option, actually, of playing over Bluetooth. No network required. Pretty cool. There's also this scenario. I didn't know that cell towers catch on fire so often, but if you go on Google Images, I don't know. This seems to happen pretty often. So this is kind of like the disaster scenario, except a little bit more localized. All right, awesome. Let's just go build these things. Let's just do it. Well, I hate to tell you this, but there's some problems. There's some serious challenges. These devices that we're using, right, our phones usually, tablets, whatever, they're super limited. They have limited storage, they have limited processing power, they have limited bandwidth, they have limited battery. Everything is limited. Of course, they're getting more and more powerful, which is why I'm giving this talk, because it's more likely that you're going to be able to do this, but they're still limited. Wireless is just terrible. If you have an Ethernet, you have like cables between everybody. right? You can communicate really easily. Wireless, we're all sharing this air. We're all sharing the same frequencies usually, and it's just terrible. If you look into how wireless works, you're like, how does this ever work? It's crazy. But multi-hop wireless is even worse, because when one device is transmitting, another one can't transmit, but you have someone in between, and you're trying to send from here to here, you have to transmit, and then they have to listen, and they have to transmit, and they have to listen. It's just a mess, right? And just a side note, TCP over wireless is really bad, because multi-hop wireless, because TCP is an end-to-end protocol. But multi-hop wireless, the problem's probably one of those wireless links. So you can look into it, but there are solutions, but basic TCP over multi-hop wireless is just a bad situation. Mobile nodes, they just won't sit still. You understand, they're moving around, the network keeps changing. That makes it very hard to network when the person you're trying to talk to keeps moving around. And self-organization is like chaos, right? Like, how do you get everyone to talk to each other? How do you give everyone addresses? And how do you agree on this is how things are going to work? It's just a mess. If you look into research around MANETs, and it makes total sense, you have to start at the bottom, right? Can we come up with better MAC protocols? Can we come up with better routing protocols? A lot of research around routing, because that's one of the main challenges in MANETs is how do I find a route from this node to that node when I don't know anything about what's going on and it keeps changing. But I'm not going to talk about that today. You can find lots of resources about it. What I'm interested in is what happens when we go to build applications that are supposed to run on these networks. They're so different. What I've basically come up with is the main challenge here is communication. If you're not communicating with anyone, who cares that you're in a MANET, right? It doesn't matter. You're just on your phone with a calculator app. It doesn't need to talk to other people. So the main challenge is communication. And what we want to know is, can we come up with a communication abstraction that's going to work in most cases for most applications? Because we know that this is going to be totally different than what you're used to. First of all, we have frequent disconnections, right? Network might be bad. Maybe someone turned on the microwave, and now your wireless is totally screwed up. Maybe one of the nodes leaves, another one comes in. I'm kind of repeating myself, but these are the big problems with MANETs. Does this happen in most networking? Not really. Yeah, there are disconnections, but you kind of assume, oh, well, that's an exceptional event, because you throw an exception when you can't make the connection, right? But in MANETs, it's commonplace. It happens constantly. So you can't just throw an exception when you can't connect. This is some app. I don't know what company makes it. This is the wrong thing to do in a MANET if you don't have a connection. You can't just be like, all right, try again later. Sorry. That's wrong. It's just going to be terrible for your users. Another problem is this addressing and discovery problem, and this is very typical for distributed computing in general. You don't want to address a resource by an IP address, because that can change, right? So you want to have some way of addressing resources that's more based on what the resource is than where it is. And there's lots of solutions to that. The other one is discovery. So again, you don't have a DNS server, right? You can't just be like, oh, I have a URL for this resource, so just tell me where the URL is. That's cool. No, it doesn't exist. There's nowhere to go for that. And there's more communication patterns than most people are used to. We're used to client-server, unicast, go back and forth. You can multicast, just send out to some group of nodes. Of course, here it looks silly because they're all kind of together, but you can imagine in a larger network. You can broadcast. You can geocast. You can say, hey, everybody who's in this region, send them a message. There's probably other ones I'm not thinking of right now. But you want to be able to support these. So what's the approach here? Well, it's kind of like distributed computing, but kind of different because distributed computing, like I mentioned before, yes, there are disconnections, but you kind of assume that your network's kind of basically going to stay the same for most of the time. It's kind of like peer-to-peer networking, but peer-to-peer networking also isn't really meant for nodes that are moving around. They might join and leave, but moving around is a totally different story. So it's kind of its own kind of thing. So I don't want to just give you a bunch of problems. I want to share with you what I've come up with as a possible solution. It's called MELON, and it's two things. I want to make it clear. MELON is an abstraction. It's a communication paradigm that might work in MANETs. I think it does. But there's also a prototype implementation, which I'll be talking about. And a very prototype. In particular, it doesn't do the discovery part. So in the code examples, you'll see, yes, you have to put in an IP address. I am aware that discovery is a whole separate problem that can be solved with a whole separate set of technologies. All right. Let's go into a little overview. The idea is you have this shared storage space. And in this storage space, you can put messages and you can retrieve messages. And it's split into two sections. One is read-only messages, and the other side is take-only. So read-only, of course, you can only read them. You can't remove them. And take-only is the opposite. You can only take them. You can't just copy them. And the messages themselves, for MELON, it doesn't really matter what they look like as long as they're kind of structured in some way, and you can match them against a template. So maybe you could think of them as like dictionaries or tuples, or maybe they just have a particular object type in them, whatever you can match on. In the following examples, they'll just be tuples or arrays, but keep in mind they could be anything that you can match with a template. MELON only has 6 operations, and it's really only 4. And they're split into this read-only and take-only. So if you want to store a single message, you use read-only message, you use write. And if you want to read a read-only message, you use read. And if you want to read a bunch of them, you use read all. And we're using read and read all. You pass in a template that matches the message. I'll show examples, it'll make more sense. And then with take-only, you use store and take all. And the retrieval methods, they can be blocking. In other words, they'll sit there and wait for a matching message. Or they can be non-blocking, where they kind of check, hey, does anybody have a matching message? If not, we'll just return either nil or empty array or something of that nature. So there's some rules for MELON. Not rules that you have to follow, but rules that it follows. The first is, when you do a read or a read all, the messages you get are messages that have not already been read by that particular process. So every time you do a read, you're going to get a different message. This is actually really useful. Because otherwise, if that wasn't the case, every time you did a read, you could get the same message. And then how would you get all the messages? Anyways, I'll show an example. It might make more sense. Messages are returned in first in, first out order, but it's only per host. So as they're being written out on a particular host, they'll be read back in that same order, but it's not a global ordering, because we're in a MANET, and trying to provide a total global ordering for anything is just impossible. Another rule, a message can only be taken once. When you do a take, it's an atomic operation. That message can only ever be taken out by one process. And of course, we're in a MANET, we have these mobile devices, we want to note that storage is limited. We know storage is limited, so we're going to just make it part of the paradigm. Say, look, storage is limited, messages might be garbage collected. Just something to be aware of. All right, so here's an example. Let's get into like a real example. All right, so there's a news server, it's going to write out messages, there's a topic and a headline. All right, so we're going to write out a message in the tech topic, and it's about this conference, just coincidentally. And we're using write because we want lots of people to be able to read it, and we don't want people to remove it because then other people can't read it. So we do that, it goes in, Now it's on the read-only side. Now another device can do a read and pass in a template. The first item in the template is the actual literal string tech, right? So it can be an actual value. And then the second one is the class. So it's like, all right, I want it to be the tech topic, but the headline, of course, can be any string. And then it will get back this message. It will get back a copy of that message. So if this device over here also did that, but did a take, well, it's not going to get any of the read-only ones because they're read-only. You can't take them. So who knows? I mean, we don't have anything over there, so maybe it gets nothing. It just blocks. I want to show you the real code, okay? Because sometimes you see these abstractions, you're like, that's nice, but I bet I have to write a ton of code to make that work, and I bet it's a huge pain, and I'm never going to do it. So here's some code. It's in Ruby. The first part is just setting up, all right? This is the server. You pull in the MELON library. You start a new instance. It uses 0MQ. You have some topics you're going to generate from. I = 0 is just so we can have like increasing headlines and we can see what they look like. And then we're just going to pick a topic. I promise not to overuse this. And then we're going to create a message with that topic and headline with the topic, and then just, the number incrementing. We're going to use write to write out the message, and then we're just going to like randomly sleep, have some pauses in there. So the output of this, I should note, for example, first of all, this is like the only part that has to do with MELON, right? That's all we're doing, melon.write, that's it. This is kind of what the output looks like. Not from that code. Well, I can't remember. Is it in there? Okay, there's no print in here, but in the real code there's a print. So it's just, these are the items it's randomly generating and outputting. The reader is even simpler, but as I said before, there's no automatic discovery. So you have to pass in an address and a port, and then a topic. It just grabs those from the command line. And then you add a remote node with the port and address. And then we're going to have our template, which is whatever that topic was, and a string. And then all we're going to do is call read all in a loop. Because every time we do that read all, it's only going to return the messages it hasn't already seen. That's all we have to do to have this stream of messages coming in, and you're never going to get the same message twice. I find that incredibly convenient. And this is the output. We only have one server. Here you can see put in localhost, the port that was random port that was used, and then I want the business news. And we have headline topic is business, and then business news item 9. And you can see these are in order, just as the server output them. So that's convenient. Of course, if we had 2 servers, they're not going to be in order anymore. But per server, they're going to be in order. All right, here's another example, but this time I left out a bunch of code, so you can just see the basic part here. So the job producer is going to produce some jobs, and then we're going to have a worker that does the jobs and returns a result. Like basic kind of distributed computing issue, right? In this case, we have a job. I don't know why you would ever send it to a worker, but we just want to add some numbers together, right? So the adder, we're going to create the new job. It's the adder, and it has some numbers. And then all we're going to do is store this time the job. We're using store and take because we only want one worker to ever take the job out. We don't want all of them to be reading it. And then we're going to get the result by doing a take, and the result is going to have the job ID, so we can kind of relate it back, and then an integer result. Because if you're adding integers, you better get integers back. The worker looks like this. So there's the template is just, all right, give me all the jobs that have an adder. And then we're going to loop, do a take, I guess I didn't use the template, sorry, with the adder. And then remember, it's like a tuple, so we need to get the first item in the tuple. And then we're going to call execute on the job, get the result, and then we're going to store the job ID in the result. And now the producer can get back the result. Notice, maybe it's obvious, but we're doing like multi-process stuff here. It could actually be inside one process, but we're not having to deal with like any threading issues, right? I mean, it's just simple. We're just storing stuff and taking it back out. And this could be across the network or not across the network. This is kind of what it looks like if you run the example code, which is in the repo that I put up earlier. So this is showing the lack of discovery. So it's like, all right, I started a server on this port, and then you get to type that port in over here. This one's like, I started here, and you get to type it there. Obviously, in a real system, you wouldn't be doing that. And then you type in the integers you want to add, it sends the job, and then you get back a result. Pretty straightforward and simple, but think of all the stuff it's abstracting for you, right? All the communication. How do I find the resource? Well, I just have this template. I don't care where it comes from. It's all taken care of for you. So MELON has a bunch of features. I kind of went over them. It has this message persistence, right? You put out a message. It can be picked up anytime later. We like to call that temporal decoupling because everyone likes to come up with cool names for things, right? So the sender of the message and the receiver of the message, they don't need to talk to each other at the same time, right? You can send a message, and I don't know, a day later, it could get picked up by someone else. So you have that decoupling there. You have this retrieval via the templates, so that's the addressing part, right? You don't have to go, hey, all right, look up the IP address for this, and then I'm going to create a socket and talk to them. No, you just say, hey, I want a message that looks like this, and you get it back. I haven't really talked about the implementation, but it's designed so that you can have a simple distributed implementation. So all the operations, the next line there, they're on demand, right? So there's no communication going on in the background here. There could be, but there doesn't need to be. When you do an operation, it starts contacting all the nodes it knows about. It says, hey, do you have this? Can I get this from you? And you can make that more or less complicated as you wish. Again, I didn't really talk about it, but it has best effort semantics, right? There are other paradigms that have strict semantics. Strict semantics do not work well in a MANET because you don't know what's going to happen. You can't make guarantees about things when nodes can just leave, literally walk off and leave. Again, I talked about this first in, first out kind of multicast. That's sort of like a fancy name for it, the ordering that you get. You have this nice bulk message retrieval. You have the stream support because you can just do read, and you'll get those messages in the order they were sent, and you won't get like duplicates. This sort of access control with the take only and read only. And then, this limited storage, which we didn't worry about. But this kind of sets it apart from going, well, we just imagine that we have infinite storage and messages never go away, or someone else will take care of that problem. Here's some graphs. I know I haven't seen a lot of graphs at this conference, so I thought you might, at the end, maybe you just need some graphs that'll pick you up, Okay, so what, right? What did this have to do with anything? Well, you remember if you went to Matt's talk yesterday, you have this idea of, oh, well, we have these little devices and we can put them somewhere, and then my device can talk to that little device, and then we can have these applications where, this device knows where that device is, and you can have a whole bunch of them, and maybe they know where their location is, and of course those devices can be much more complicated than that, right? So this is something that exists. You can go out, you can buy them, they're pretty cheap. Talk this morning. Autonomous devices, cheap. You can program them. They have wireless. They could talk to each other. They could move around on their own, right, and be talking to each other. So this technology is here. We all have phones that are super powerful, and they have like 5 or 6 different types of radio devices in them. We can use that if we wanted to. I don't know about you guys, but I've been doing this for many years now, and it never occurred to me that the abbreviation for vehicular networks is VANETs, which says van in the name, and is just brilliant. So I've been talking about what you might call like pure MANETs, right? We have mobile devices, they move around, they're kind of small, and they can talk to each other. It doesn't have to be like that. You can have vehicles talking to each other. You can have vehicles talking to devices, talking to other vehicles. Sensor networks is a big area. You have these small little devices, they have sensors on them. They can talk to each other, they can talk to your device, they can talk to vehicles passing by, all kinds of configurations. Another one I like is these delay-tolerant networks. I heard a presentation several years ago. You have these villages, maybe in Africa or other rural areas, and they don't have internet access, right? So we have a bus, right, that carries people, but it also carries, some kind of server. So you're in the village, you're like, oh, I got to email somebody. You write up your email, you wait for the bus to come by, you send it to the bus. The bus eventually makes its way back to a city and unloads all those messages. I mean, that's pretty cool. There's also a bunch of stuff with buses talking to each other, talking to all sorts of things. And of course, you heard this morning, this Internet of Things, right? It's just things on the internet. Well, they don't have to be on the internet. They could also just be talking to each other. They could be talking to each other and the internet. So all sorts of opportunity here. Here's some resources. I think, like I said at the beginning, the time is right for this kind of thing. We have all these different devices, they're becoming more and more powerful, and guess what? People have been saying they're becoming more and more powerful for years, but now they really are powerful, right? If they can run JavaScript, they're powerful, right? So I encourage you to kind of think about this, think about how it could be used, think about the applications, and if you want, here's some resources. I know this is an RFC, but it's incredibly readable. Like, don't be scared by the fact that it's an RFC. It's a really good overview of MANETs, the challenges, what makes them different, things like how do we do the routing, how do we assign addresses, of course, IPv6, I found this chapter in the 0MQ guide. I don't even know why it's there, but it actually talks about MANETs and, like, from an application standpoint, how do we do, again, discovering, addressing, how do we organize, how do we do the communication. This is my academic page. If for some reason you wanted to read more about this, there are a couple papers there. Or you could just go and look at the implementation on GitHub. So I hope I've made it clear and haven't repeated it too many times that this is the kind of thing we're going to need, right? This idea of an abstraction for communication. It's a different kind of world than we're used to, very different, because we're used to, okay, here's the client, here's the server, they're going to talk, yeah, I have to deal with, messages being dropped or whatever, but, it's just me and the server and it's good. It's not like that anymore. It's not going to be like that. So we need these abstractions. And MELON is just one abstraction. I think it's a good one. I think it's better than a lot of the traditional distributed computing ones. Not for distributed computing, but for MANETs, because distributed computing wasn't meant for MANETs. So there may be other ones, but these are the kinds of things we're going to need if people are going to do something as simple as like using Heroku to launch a web app, right? You need this kind of infrastructure to say, all right, well, I'm going to create an application that runs on this kind of network. I don't want to have to be writing socket code. Doesn't make sense. All right, I think I've belabored that point enough. So thank you. Thanks for sticking it out to the end. And you can find me on the internet at President Beef. All right, so plenty of time for questions because nobody wants to go home, right?
So for people who might consider working on this and developing applications to work on MANETs, what kind of regulatory concerns are there for using wireless networks in this way from the FCC or other regulatory bodies?
I'm not totally familiar, but I mean, you're just using Wi-Fi. So I should say, of course, there's lots of standards that have been proposed for these kind of networks, and I think it's going to come down to we're going to use Wi-Fi or some version of Wi-Fi because that's what kind of all the devices have settled on. So I don't think there's any real concerns with using Wi-Fi for these kind of networks. At least I hope not.
Hey, how's it going?
Good.
What's the killer app for this stuff? I mean, it's not like I'm imagining if I'm working on it's actually really original. It's a mobile social photo sharing application. For my mobile social photo sharing application, like, why would I put myself through this? You know what I mean? What is the context in which it is like worthwhile for me to make these sort of trade-offs versus just assuming there is some server out there that I can use to coordinate this stuff?
Right. So, first of all, what is the killer app? That's what you guys are supposed to come up with, right? No, I think, like I said, I think anytime I think there's two things, and I went over them, but anytime you're in an area where cell reception is not good, but the person you want to share something with is not that far away, you can imagine a high school. I mean, that's like, teenagers send like thousands of texts. Why do they need to go over the cell network when their friend is in the same building, right? They might not be within one hop, but they're probably within 2 hops, right? For your photo sharing application, again, it's like if I want to share a photo with you, maybe I don't want to use my data plan. Maybe there's no cell reception. Maybe I don't want to connect to the wireless here. I just want to send a picture to you, my friend, right? So it's those kinds of things. And I don't think that this is going to be something where you can ignore it, right? We like to be able to abstract things and ignore them. You can't ignore the fact that you're in a MANET. You just can't. It's too weird. It's too different. You need abstractions, like MELON maybe, but you can't ignore the fact that you're in this really different kind of network. Ideally, your device would be able to just do all the connections for you, but you're still going to have to be aware of the fact that you're not just sending it up to a server that will figure it all out for you. I don't know if that answered your question. Maybe? Sorry.
If I'm developing an application in the United States, then like I'm going to assume that cell coverage is going to be good enough. If I'm thinking of like what this would be good for, I'm thinking like sub-Saharan Africa. So what is the compelling killer app in sub-Saharan Africa? Like what do they not have in a place where there really is nothing like remotely like good cell coverage? Or I'm thinking of like sensor networks, like micros for like monitoring earthquake stuff or oil and gas stuff, something where like you were really out in the middle of nowhere. Just to kind of get this stuff started. I kind of wanted an answer to my question. I cheated. I had an answer in mind.
No, I mean, you're absolutely right.
But it's like thinking in terms of like general purpose application developers, people who are going to be like, working on mobile social photo sharing applications. This is not the audience you want to be talking to. You want to be talking to people who are doing oil and gas, people who are doing weird stuff.
See, that's where I disagree slightly.
Okay.
Because I think you're right that those are the areas where it will start. But I think we all need to be aware that this is an option for us, or it will soon be an option. And for something to really be mainstream, like you said, there has to be a killer app. But the things you're talking about, like monitoring and sensor networks, they're really kind of narrow areas.
That's true.
And
That's right.
I want this to be something that everyone's aware of and like, hey, for our app, like if there's not cell connection, let's try like doing something else, right? And it's that kind of vertical handoff, if you can do it, between network types. I think it's pretty cool.
I would say don't knock niche applications. I mean, like Hadoop stuff got started with, crazy Google, Facebook, Twitter, for God's sake.
But the thing is that these, I'm not trying to argue with you, but
I know, and I'm trying to argue with you. I'm that guy. I'm sorry.
The applications that you're mentioning, they do know about this. There are lots of projects in these areas.
Yeah.
But what I'm trying to do is share it with a wider audience.
So then maybe privacy stuff, if I don't necessarily want Verizon or Comcast or whoever logging the fact that I'm having a conversation
That's a good
with
idea.
someone.
Unfortunately, privacy and security in MANETs is like a really hard problem too. Because how do I verify you are who you are? How do I make sure my communications aren't being overheard when nobody's going anywhere? You can leave if you don't want me to continue rambling.
I'm sorry. It was great. Like, I really enjoyed the talk, and this is super, super interesting stuff. Yeah,
All right,
yeah. I don't mean to give you a hard time. All right.
Thank you.
Thank you.
Definitely ask me questions after if you're interested. One more, two more. You're gonna end this, but the guy behind you wants to ask a question.
You want to ask a question? You could feel free, but let me talk before everyone runs. No, go ahead. Sorry.
I know there is one cool app for the iPhone called FireChat, and
Yes.
it uses, I assume, a technology like a MANET, but it's a...
Yeah, so someone reminded me yesterday, I don't know if you're here, about FireChat. So when it came out and I saw all the blog posts about it, I was like, whatever, like, this has been around forever, right? Because, I want to give these kind of talks. When I looked into it, yeah, there's not really much information about how they're doing it. They're keeping that pretty secret. But, I mean, that's a good example of an application that's doing that today. But that's just one, and I think there could be many, many. And hopefully using more general purpose approaches that we can all share.